Alright, we're looking at how to graph rational functions here. What you need to do for each one of these is first to factor both the top and the bottom. So in this case you'd have a 2 times x minus 3, and you can't factor the bottom at all. So there's your factored form. The other thing you should try to do is long division for each one of these. The top always goes on the inside, bottom on the outside. How many times do you have to multiply? What do you have to multiply x by to get to 2x? You just multiply by 2. So that will give me 2x plus 6. I need to subtract. I'll get negative 12. So my remainder will be negative 12, and I put that over my original divisor. So when I do that, I now have all the information that I need to know to find all of this information. So starting with domain, we have domain issues whenever the denominator equals 0, and that's at negative 3. So I'll go from negative infinity to negative 3, and then from negative 3 up to infinity. My vertical asymptotes are wherever the bottom equals 0, that doesn't cancel out with anything up top. Well, here again, nothing cancels. That's why my vertical asymptote is at x equals negative 3. If it did cancel, that would become a hole. Nothing canceled out, so I do not have any holes. My horizontal asymptote, or my slant asymptote, comes from the division. Whatever my answer is in the division, right here, 2. That's a horizontal asymptote because no x is involved. If I had an answer like 2x plus 5, that would be a slant asymptote. That's what we go there. But because we have no x's involved, we do not have a slant asymptote. Alright, my intercept. X-intercept means I set the whole thing equal to 0. That means I set the top equal to 0. So I'll have an x-intercept when x equals 3. The ordered pair is 3, 0. My y-intercept is plugging in 0 for x. So I'm going to have negative 6 over positive 3. So I'm going to have 0, negative 2 as my y-intercept. And where does it cross the horizontal asymptote? It crosses the horizontal asymptote whenever this guy equals 0. The remainder equals 0. Well, that can never happen because negative 12 never equals 0. The number cannot equal 0 unless it's 0 itself. So, plugging these in, we have first graphing the vertical and horizontal asymptotes. So there's the vertical asymptote at x equals negative 3. The horizontal asymptote is at y equals 2. Now I plot the points that I know. The points that I know are 3, 0 and 0, negative 2. So I'm going to have that part looking here. Now I need something on this side of the vertical asymptote as well. Is it going to be up top or on the bottom? Well, if it was on the bottom, I would have to cross this axis again, but we only had one x-intercept. So it has to be up here as a result. Alright, let's look at this next one. Same thing, factor the top and the bottom. Top's already good. This one's going to be x minus 2 and x plus 1 on the bottom. My domain again is wherever these breakpoints are. So it'll be at 2 and negative 1. So what comes first is the negative 1. So then I go to the next breakpoint, which is 2, and from 2 to infinity. Those are both vertical asymptotes because neither of them cancel out. So x equals 2 and x equals negative 1 are both vertical asymptotes. So I'll get those and plot them right away. X equals 2 and x equals negative 1 are my vertical asymptotes. Okay? Horizontal asymptotes. To find those, we need to do the division again. So this goes on the inside, and this guy at the bottom go on the outside. Well, here's the thing. Anytime the degree of the numerator is smaller than the denominator, it's like you've already done the division. You can't multiply x squared by anything to get x. So really, we've already done the division, and this is our remainder. It's like we did 0 plus, that's your remainder. So that means our horizontal asymptote is y equals 0. And that'll happen anytime you cannot do long division. So again, that means there's no slant asymptote. X-intercept, when I make the top equal to 0, that means I have the ordered pair 4, 0. And y-intercept, when I plug in 0, negative 4 over negative 2, gives me 0, 2. There are no holes because nothing canceled out. And when does it cross the horizontal asymptote? It crosses it when this top equals 0. So if I set that equal to 0, that means that, well, again, my remainder equals 0, so x equals 4. So, my horizontal asymptote, y equals 0, I can graph that now. And then now let's plot the points I know. I know 4, 0, I know 0, 2, and I knew x equals 4 is where it crossed the horizontal asymptote. So there it is. I'm touching it already, so I'm in good shape there. That's the only place I'm allowed to touch. So, because of that, I can't cross the horizontal here. That means the only possibility is something that looks like this. For something in the negatives, let's say I plug in -3 because it's over here. I don't know if it's above or below yet, and I can't judge it based on the axis because that is the asymptote. Well, if I plug in, let's say, -4. -4 up here gives me a negative up top. -4 here gives me negative and negative again. A negative divided by a negative divided by another negative is negative. So that's why I must be below the axis over there. And now, again, I need to see, am I going from the bottom and going up, or from the top and going down? Well, let's plug in a big number. Let's plug in 10. If I plug in 10, I have a positive here, and a positive there. So it means when I'm at 10, it had to be positive. So it means it would have had to have gone something like that for your answer. Alright, let's do a couple more. I would suggest pausing the video, seeing if you can set up these last two, and when you're ready, go ahead and hit play again and see if you can get the correct answers. Alright, let's see how you did. First things first, factor the top. I would get x minus 3 and x plus 2, and then x plus 4 on the bottom still. For this one here, I can factor out an x, and then I would still have x squared minus 2x minus 3. So I have x minus 3 and x plus 2, or x plus 1 I mean, I'm sorry. And on the bottom I have x minus 1 and x plus 1. Alright, let's also look at long division. The top is bigger than the bottom, so I can do the division. X plus 4 on the outside, so I would have an x here because x times x gives me the x squared, then plus 4x. I subtract that to get a negative 5x minus 6, so this needs to be negative 5, give me negative 5x minus 20. When I subtract those, I should get I should get positive 14. So my remainder is positive 14 over x plus 4 is my extra remainder there. When I do this one, same thing, x cubed minus 2x squared minus 3x, divide that by x squared minus 1. I will have an x. I will get x cubed minus just an x, so when I subtract those, I'll have a negative 2x squared, 3x minus a negative x gives me plus 2x, and then I can plug in from there. I would need to have a negative 2 to give me negative 2x squared, and then I would have a plus 2 at the end. And that would leave me with 2x minus 2 as my remainder. Okay? So now let's plug in, or let's figure out what everything we know. Only domain issue is that x equals negative 4, so it's negative infinity to negative 4, and negative 4 up to infinity. My vertical asymptote, that's what it is. X equals negative 4, because we do not have anything that is canceling out at the moment. So that means that there are no holes in this case here. Okay? Horizontal asymptote is this part right here. So it would be y equals x minus 5, but because there's an x there, it's not the horizontal asymptote. That's called a slant asymptote. The line y equals x minus 5. X-intercepts, when I set the top equal to 0, so I should have two of them here. I should get 3 comma 0, and I will also get negative 2 comma 0. Y-intercepts, when I plug in 0, I should get negative 6 over 4, or negative 3 halves. Negative 3 over 2. No holes, does it ever cross? No, it does not, because 14 doesn't equal 0, so it should not cross the asymptote. So when I graph these, first the asymptotes, vertical asymptote at y equals negative 4, and then a horizontal asymptote doesn't exist. The slant asymptote is y equals x minus 5. So it should be this line looking thing like this. That'll kind of go down like so. Alright? To plot the points that we know, I should have the points 3 comma 0, negative 2 comma 0, and a y-intercept of negative 3 halves. Okay? So this kind of makes this part pretty easy to graph, where I can get it to follow the asymptotes quite nicely. Now, my other question, on the left side of this vertical asymptote, is it up top or down below? Well, if it was up top, it would have to cross this axis again, so that means the only possibility is it to be down here somewhere. I can get that to show back up. It'll show up down below that asymptote on the bottom and look something like this down below it. Alright, so that should be everything for that one. Let's now look here at number 4. With number 4, I should be looking at, I have the domain already figured out. Now, here's something to look at. Domain, it doesn't matter if things cancel out or not. The only thing I'm worried about for domain is just where are my breakpoints, which are at -1 and 1. So negative infinity to -1, -1 to +1, and 1 to infinity. Now, the x plus 1's cancel out. That means this x equals -1 is not a vertical asymptote, it is a hole. There's a hole at x equals -1. The positive one is still a vertical asymptote, so I'll still have this vertical asymptote at x equals +1. Horizontal asymptote doesn't exist. My horizontal asymptote, or my slant asymptote, I mean, will be y equals x minus 2. So that should be something that looks kind of like that. Okay, x-intercepts are when the top equals 0. Well, I should have had 3 points here. I should have been 0, 0 for the x, 3, 0 for the y, and then -1, 0 for this last one. However, that one cancels out. It's not in our domain at all, so we shouldn't even have it. Y-intercept, when I plug in 0, I'll get 0, so 0, 0. And crossing the asymptote, that would happen at this point. When 2x minus 2 equals 0, that would mean 2x equals 2 or x equals 1. So when x equals 1. But guess what? That was not in our domain. It was a hole that got, it was a hole. I mean, it wasn't even a hole. It's not in our domain because we can't divide by it. So this one really we don't even have to worry about either in this case. But that's how you would know if it did cross the asymptote. So now let's plug in the points we know. The points we know are x-intercepts of 0, 0 and 3, 0. And the only way I can follow the asymptotes here is something like this on this side. And now over here, did I go from positive to negative or negative to positive? Well, it's pretty straightforward. It's going to have to go just like this. That's the only way I can follow my asymptotes. Now the only thing left is there should be a hole when x equals -1. So I should have a little hole like that, and then I should really erase everything on the inside to make sure it's definitely a hole there, because the function cannot exist at that point. Alright, well that's all you need to know for graphing rationals. You need to be able to do each and every one of these steps and then put them all together at the end to make a general picture of the graph.